Dear students, today we will see the new topic 555 timer IC. Today the topic is description of functional diagram. Before we are going to the functional diagram, we will start with the basic need and requirement of this 555 timer IC and few application about this 555 timer IC. The 555 timer is a highly stable device. For what? For generating the accurate time delay and oscillations. This is very important to know. It is a highly stable device for generating the accurate time and oscillations. This 555 timer IC made in either as 14-pin dual in package with two timers or single 8-pin dual in package with one 555 timer. Today we are going to see what is the description of the functional diagram of single 8-pin DIP package. The supply voltage it's vary from 5 plus 5 to maximum of plus 18. Very important, note down. The supply voltage is vary from plus 5 to maximum of plus 18. It can drive the load up to 220 milliamps. So it is very important to know this is working in the way of two logic. One is a transistor logic, another one is a complementary MOSFET logic circuits. See, with the 555 timer IC, I can design many applications in the real-time systems, like to measure the heartbeat. Very few applications are listed here in the slides, not limited to this. Oscillators, pulse generator, some missing pulse detector, ramp, square wave generator, monoshot multimeter, burglar alarm, traffic light control, voltage monitor, many. It's a very important IC to do many to solve the problem in the real-time system. So now we will go for the what is the pin diagram for the 8-pin package. The first pin is a ground, very important, ground. The second pin is a trigger, third is your output, fourth is your reset pin, fifth is your control voltage, and sixth is threshold, seventh is discharge, and eighth is supply voltage, positive supply voltage. Repeating again, the first pin is a ground, second pin is your trigger, and third pin is your output, and fourth pin is your reset, and fifth pin is your control voltage, and sixth pin is your threshold, and seventh pin is the discharge, and eighth is your supply. For this pins only, we are going to see the description. Okay, see, this is a simple way, and I can say it's an easy way to understand the description of your 555 timer IC. So this is the first pin. We know that the first pin is your ground. You can see this is the first pin. Second pin is your trigger, and third pin is your output, and fourth pin is your reset, and fifth pin is your control voltage, and sixth pin is your threshold, and seventh pin is your discharge, and eighth pin is your DC supply. Now I will explain you the important blocks which is given in this functional diagram. The first part is your divided network. This R1, R2, R3, it is act as a voltage divider. Here it is a comparator. Here it is a op amp. This op amp, it working as a comparator in this diagram. For 555 timer IC, here this op amp is working as a comparator circuit. Here you can see two comparator circuit. One is upper comparator and lower comparator. The upper comparator is given as a C1 and lower comparator is given as a C2. First I will explain what are the important element, then I will explain the circuit. These are necessary points we will discuss. Then is there flip-flops. Here is we are using flip-flop. Then here you have a PNP transistor. You can see the arrow is towards the base. That's why I am saying it's a PNP. And this is your NPN transistor. The NPN transistor is named as Q2 and PNP transistor is named as a Q1. And here you can see it is connected to inverter and inverter output is connected to the output terminal. So this is a important element which is present in this circuit. Now we will go to the basic. Okay, so basically we will be starting with this divided network. Okay, so here you have a, you can see you have a 5k resistors, internal resistor. This is acting as a voltage divider. So it is very important to know the 555 timer IC naming. So why they kept the name 555 timer IC? Because of this arrangement only. Because of this arrangement only, the name they kept 555 timer IC. It is acting as a divided network. Right. So next thing is your comparator. Okay. We'll go for the comparator basic, then I will come to this circuit again. First we'll see what is a comparator, then only you can understand this diagram. What is a comparator? So here it is an op amp. It is working in the open loop gain without any feedback. You can see clearly. How you want to understand this comparator logic? Very simple, very simple. You take this V in as a V1 and V ref as a V2. Always if V1 is greater than V2, you please remember V1 is should be connected to positive and V2 is connected to the minus terminal. If it is greater, whatever terminal which is connected to plus, if it is greater than the negative terminal, the output is VSAT, output is plus VCC. So you can see now. So explained you clearly. If V1 is greater than V2, the output is plus VCC. If V1 is less than V2, your output is minus VCC. This logic is very important because in our functional diagram, we are comparing the trigger voltage and threshold voltage with the another terminal of your comparator, upper comparator, lower comparator. Without this knowing this logic, you can't understand the discriminational diagram. So first we'll learn this, then we'll move on to the slide. Okay, now I'll go to this functional diagram. Now you can see here they have mentioned 2 by 3 VCC and 1 by 3 VCC. What is this? It is a bias voltage. It is a bias voltage which is generated from this VCC because of this divided network to the upper comparator and lower comparator. How? We will see now. Okay, let me take this divided network. 3 resistors I connected, ground, R. Let me calculate for this point. What is the output? You know the divider rule, right? We want to use the divider rule. So what is the supply voltage for this network? VCC. What is the corresponding resistance that is towards the ground? R. What is the total resistance in the circuit? Total resistance R, 2R, 3R. So R will get cancelled. So VCC by 3. So this bias voltage, that is this network, divided network, how much it will provide? 1 by 3rd of your VCC. Okay. Similarly, if you put for this second resistor, same logic, but you are taking at this terminal, right? R plus another R, 2R towards the ground. You want to take you want to find this point. So your supply voltage is VCC, right? So VCC 2R divided by total resistance is 3R. R will get cancelled. 2 VCC by 3. So that is a bias voltage, right, from the network which is sent to the upper comparator. I hope you understood. We'll go to the next part of the circuit. See now, see very important concept. The positive terminal is connected to threshold and negative terminal is connected to the trigger, right? So already I said the comparator will compare these two voltage. If it is greater, 1 will come. If it is lesser, you will get a 0. Here the plus terminal is connected to threshold, right? So threshold voltage. What is the logic? If threshold voltage is greater than your 2 by 3rd of your VCC, you will get the logic of 1. That means upper comparator will give the state of 1. That's all. Very clear. Understood or not? I'm repeating again. If threshold voltage is greater than 2 by 3rd of your VCC, you will get the logic of 1. Otherwise, you will get the logic of 0. That's all. Similarly, here you see it is connected to plus. That means VCC by 3. VCC by 3 should be greater than the trigger input. I hope you seen clearly. See, here plus is connected to threshold. That's why I am taking threshold is greater than 2 by 3rd of your VCC. That is from the bias voltage. But here you see the plus is connected to 1 by 3rd of your VCC. So that means this should be in the left and other value should be in the right. If your VCC by 3 is greater than trigger only, the lower comparator will set. Otherwise, it will not set. Okay, that means you will get a logic of 1, otherwise you will get a logic of 0. Very simple. So this is the logic you want to understand. If upper comparator work means your threshold voltage is greater than 2 by 3rd of your VCC, otherwise you will be getting a 0. If lower comparator is on means your 1 by 3rd of your VCC is greater than the trigger input. That is the logic. I hope it is clear. Right. So you can see here the fifth pin is named as a control voltage. Okay. So by using these resistors, I can determining a timing interval. Right. The another reason why this control voltage is connected is I can modulate. By enabling this control voltage, I can modulate the timing interval. So I can possibly to vary the time electronically by applying the modulation voltage to the control voltage input terminal. That is the need of this control voltage terminal, right? To vary the time electronically by providing the modulation voltage to the control voltage input terminal. If you are not using this terminal, right, if you are not using this terminal, so it is recommended to connect with this some capacitor to be connected to avoid some ripple from the supply or some noises to avoid. If you are not using this, it should be connected to some capacitor. Okay, so I hope you understand. So I explained you what is a divider network. From here, what is the bias voltage which is sent to the upper comparator and the lower comparator. Then I explained you the logic of these comparators, and now we will move on to the flip-flop. First we will know what is a flip-flop, then we will go back. What is a flip-flop? Flip-flop is some storing device. It is used as for storing the data elements. The flip-flop, it stores single bit. Is a device, it stores single bit of data. Either state can be 1 or other represent 0. Here we are using SR flip-flop. S means set, R means reset. Understand? S means set and R means reset. So we have many flip-flop, but here we are using SR flip-flop. If set is 1, your output is 1. Please remember, very important. If reset is 1, your output is 0. If both are 0, 0, you have a previous state. That is no change. If both are 1, 1, you have an invalid state. I am repeating again. If set is 1, Q will be 1. If reset is 1, Q will be 0. This is very important. Okay, so this logic is very important to understand the functional diagram. Okay, see now, if upper comparator, when this upper comparator will set when threshold is greater than 2 by 3 VCC. When lower comparator will on, when VCC by 3 is greater than the trigger, you take your lower comparator is on. If S is 1, obviously reset should be 0. If S is 1, Q should be 1, right? Then Q bar is connected to, it should be 0 only, right? So it is connected to inverter, so you will be getting the opposite of this 0, 1. Okay, now see, this 0 is sent to this Q2 transistor. So this is NPN transistor. If it is 0, so please remember, if transistor, if I am giving 1, here it will be on. It will be act as a short circuit. So what it will do? It will discharge. It will discharge. Note down, it will discharge. Very important. If I am giving 0, the same transistor will act as a open circuit and it used to charge. It used to charge. So I am repeating again, if transistor is on, it used to discharge. If it transistor is off, it used to charge. When it will on, when you are providing 1. When it will off, when you are providing 0. Okay, because this base emitter junction, it want minimum of 0.6 to 0.7. Then only this will switch on your device. Okay, so if it is on, it will discharge. It will discharge. Right, so it will discharge. If it is charging, means it is, the transistor is off. That you want to remember. It is connected to 7th pin. So this pin is very useful when you are going to learn about unstable and monostable. Okay, with this only the entire logic is being decided. Okay, now very important pin is a reset pin, another pin. So you can see here reset. What do you mean by reset? Reset means if you press the reset means the entire history will be deleted. So it will go to the initialized condition. So that is, I can say it is a mechanism to reset the flip-flop. How it will do? It will override. It will override. It will override. Right? Generally, what happen means reset is connected to transistor and it will control the flow to the flip-flop. That is basically what actually happened. So if you are giving the reset, if the transistor have to switch on means you should provide less than 0.4 because it's a PNP transistor. It is a PNP, so you should give less than 0.4. If you are giving less than 0.4, it will override the instruction which is coming to the flip-flop from the lower comparator. I am repeating again. So it override the effect of any instruction which is coming to the flip-flop, from the lower comparator. Right, if when reset is not used, please remember, when reset is not used, it is returned to VCC. It is returned to VCC. It is returned to VCC. So this is a very basic logic of reset pin 4th, and other pins are I explained you clearly. Right. So this is a functional diagram. So here I have given the explanation also, you can see here. So I'll just go fast. Okay, so everything I explained you in the diagram itself. You can go through the slides. Okay, already I shared the slide. You can go through it. Right, you have a 5K internal resistance. It acts as a voltage divider. Right, so from the divider network only, you are providing the bias to the upper comparator and the lower comparator. Very important, valid point, very important point. With this knowledge only you can able to understand. This voltage levels are threshold for the comparator, and based on this only the timing interval will be decided. See, every point already I explained you. By providing the input in the 5th pin, that is a control voltage, time can be varied electronically. Time can be varied electronically. So very important, the time can be varied electronically. So if you are not using you should connect some capacitor between phi and ground to bypass noise and ripples. Okay, so initially it will be in the stable state, right? Initially it will be in the stable state, so flip-flop is high. Okay, so the output of Q of flip-flop FFS is high. That means Q will be always 0. That is in the initial state, right? Q will be 0, Q bar will be 1. So that's what is given here. So output to low from the power inverter. Okay, then then like a na, so then you have a lower comparator and upper comparator. Okay, in the upper comparator, you have a threshold pin and 2 by 3 VCC. If sixth pin is greater than 2 by VCC by 3, what happened? You will be having of 1, right? If it is greater, you have a logic of 1. Otherwise, you have a logic of 0. Similarly here, the lower comparator, your VCC by 3 will be below VC by 3, means your lower comparator will go high. Understand? So very simple. For a lower comparator, VCC by 3 is connected to the comparator terminal, right? It is connected to the comparator terminal. You can see here. So condition is if 1 by 3 VCC is greater than this trigger input, this will on. S will be 1, Q will be 1, Q bar will be 0. Same is given in the slide. If upper comparator auto on means the threshold should be greater than the 2 by 3 VCC. Then this will on, R is on. If reset is 1, Q will be 0 and Q bar will be 1. So that's what is explained here. Okay. So similarly, I said everything about reset pin 4.